So question 8, question 9, I mean, this is question 9.
Excuse me, sir.
Go ahead, excuse.
For question 8F, you would have gone with the right hand side. It would have been simpler. Can you get me?
I can get you.
Yes, because that one, it's a difference of two squares. Then you get rid of the one of those, and you remain on the right hand side. You get it?
It will be the same procedure.
Yeah, but it would have been simpler than these other ones, more complicated.
Because look,
maybe we can just continue.
What I'm seeing here is that the right hand side has a difference of two squares in the numerator. So you need it to cancel one of the denominator. Then you remain without the square, and then you multiply again by the denominator, by the numerator this time around.
Yeah, so I was saying you'd have gone with the right hand side, no? It would have been much simpler to understand, yeah. All right, thank you.
Okay, let's do it. So that those who missed it have that understanding. It was sine x plus cos x, it's squared. And then you also have sine squared x minus cos squared x being equal to sine squared x minus cos squared x over sine x minus cos x squared. So you pick a choice of the right hand side. Difference of two squares on top there gives us sine x minus cos x multiplied by sine x plus cos x divided by sine x minus cos x. Since it's squared, it's meaning that it's being multiplied by itself. So this piece goes with this one. You end up having sine x plus cos x over sine x minus cos x. So the only way we can have the square on top is by multiplying the top part by itself, which is sine x plus cos x. But if you do that, you'll be forced to multiply also the down part by the top part. Then on top, we now have sine x plus cos x.
So on the second step there, why is it that it has become negative cos squared there on top? But on the starting here, it has got positive cos x.
I can't see why. I can't get what you mean. Why has it become positive? Because this thing here, this is negative. This too is negative. Just like we have negative in the question.
No, on top, on the starting point where you've started from here.
So what we have as a numerator is a squared minus b squared.
Yes.
This is a difference of two squares. So you can factorize it in this way. Because we know that the expansion of this is a squared plus ab minus ab minus b squared, which becomes a squared minus b squared.
I'm saying on the numerator there on top, numerator. Here on the starting, on the question here, on the first part, there is a numerator which has got a positive. Now here on the second stage, where you are calculating, it has changed into negative on the numerator.
We expanded.
We started with the right-hand side. This here, which has a negative in the numerator.
Oh,
Not the left, which has
right,
a
okay.
positive. So then the
All right.
denominator of the second part is having this piece here, meaning that it can be taken to this one. And so we'll write it as sine squared minus cos squared, which becomes the left-hand side. So I've done both ways so that you guys can have the choice. This question now, John. Question 9. Use the addition or subtraction formula to find the exact value of the given expressions.
Sir,
Yes.
before you go to question 9, can't you solve 8H?
Now the identities are so many, so you can't solve all of them. So you crack your head there and solve H. Whichever way you're going to use. You start with your H sine 4x minus cos 4x is equal to sine squared x minus cos squared x. Okay. Since we know that we can write, let's start with the left-hand side. We can write sine 4 as sine squared x power 2. We can write cos 4 as cos squared x power 2. Then it's a difference of 2 squares. So you have sine squared x minus cos squared x. You also have sine squared x plus cos squared x. But this identity here is equal to 1. So you remain with sine squared x minus cos squared x, which is the right
All right,
answer.
thank you. It even looks simple. I thought it's difficult.
Not one.
Sir, can you go back to the previous screen?
So question 9, use addition or subtraction formula to find the exact value of the given expression. We'll start with B, the easiest. Sine 15.
Thank you.
Okay. So B, sine 15. So 15 can come from 45 minus 30. And then we expand that sine 45 cos 30 minus Sine 30 cos 45. Sine 45 is root 2 over 2. Cos 30 is root 3 over 2. Minus sine 30 is half. And cos 45 is root 2 over 2. So this is root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 over 4. Okay, you can make now your own choice. So me, I chose B. Someone else can choose anything. So that if there'll be no choice, then we'll move to question.
So you can't find the difference between root 6 and root 2.
You can't, because unless you know the actual value of root 6, or unless you're able to write root 6 in terms of root 2. But if you try, that would be root 3, root 2. So they not change.
You can go to G.
We can go where?
G.
D.
Yes.
G is tan 105. Now 105 can be written as 90 plus
G, sir.
D.
G.
Oh, G. Where is G now? Okay, G. G is tan 73 minus tan 13 over 1 plus tan 73 tan 13. Now we know that tan A plus B tan A minus B is tan A minus tan B over 1 plus tan A tan B. We know this. So what we have is the right hand side. So we need to use the left. So this is the same as tan 73 minus 13, which is tan 60. And tan 60 is root 3 over 2 over half, which is root 3.
Repeat sir, pamoja.
So if you know this identity here, which is the key thing, then if you are given the right hand side, so you can rearrange them in the left hand side way. Because here it's like we are given the left hand side, so we have to look for the right hand side, the expansion of sine. So if I'm given the expansion already, then I'll look for the other way which is not given. We won't be able to find this, because you can't find tan 13 unless you're using a calculator, but not in this course. No calculators. So then you use what you know. Another question? From here,
H.
Excuse me, sir. Infix to that.
what did you say?
On the denominator part where there is 1 plus tan 73 tan 13, it doesn't add any infix to the top equation.
Mm-mm. The effect is in this form. Since we have this thing on the right, we want to use this thing on the left. Since the two are equal.
Sir, repeat your reason.
We are saying, since we know that tan A minus B is expanded as tan A minus tan B over 1 plus. And the question we have has minus on top, plus down. So we just pick the angles and put them in the form of the left-hand side. 73 minus 13. And we are still using tan.
So, sir, what
I
if we
didn't
had,
get it where the 1/2 came from.
Oh, I was doing tan 60. I did it in the form of sin 60 over cos 60. That's the easiest way I remember these things. Because I know sin
So what
60
if you
is
just go there to say tan 60? What?
you say it is root 3. For as long as you remember it that way, it's correct.
Then we can't panic to go about root 3/2 over 1. Jashan.
That was my skill of remembering.
All
So
right.
if your skill is direct, then you use it as it is. Exactly.
Okay.
so, sir, what if we had tan A plus B?
Your question would have come with plus on the right, in the numerator. And they would have changed the angles. So this question is designed in such a way that when you do the angles, you get a special angle. If you find the solution. Okay, this was question 9. What question 10?
Sawa, ukasema chako na H, sawa.
H is cos 13 pi over 15 cos negative pi over minus sine 13 pi sine negative pi over 5. So the only thing we expand like this is cos A. Is that plus or minus? It's minus. It's cos A plus B. It's expanded as cos A, cos B, minus sine A, sine B. So since you have this, you use the left so that you'll be dealing with sine. You'll be dealing with cos. Oh, cos. What are the angles now? Where are they? Cos 11 pi. Cos 13 pi, I mean. Cos 13 pi over 5 plus negative pi over 5. Then you find the solution.
Okay, sir.
Question 10.
The screen, sir.
Prove the following identities. That's question 10. Always start with the simplest. The simplest is A. Tan pi over 2 minus x. Show that this is the same as cot x. So we'll start with the left hand side. Say tan pi over 2 minus x is the same as sin pi over 2 minus x over cos pi over 2 minus x. But on the top one is the same as sin pi over 2
Excuse me, sir.
cos x, yes.
So using the last identity, this can't work out.
But tan 90 is undefined. So it can't work out. So minus cos 90 sin x over cos 90 cos x plus sin 90 sin x. But sin 90 is 1, so we get cos x. Cos 90 is 0, so we get 0 there. Cos 90 is 0, sin 90 is 1. And this is cot x. Why
Come
can-
again, son, the second last step.
Because the second last step is about knowing the values of sin 90. What is sin 90? It's 1. So 1 times cos is cos. Cos 90 is 0. 0 times sin is 0.
Sir,
Mhm.
can we use that formula for tan, the previous one?
You can't. Tan 90 minus x will be the same as tan 90 minus tan x over 1 plus tan 90 tan x. But tan 90 is 1 over 0, which is undefined. So you can't use what is undefined.
Oh, okay, sir. We'll change it.
But it's too tempting, sir.
No matter how tempting it is, you avoid the temptation for the betterment of your future. I'm not a boss. Let's go to question 11. Or there's any question of
E, sir.
which one is E now?
E.
E is tan x minus tan y. Show that it's the same as sin x minus y over cos x cos y. Let's start the right hand side. Looks a bit easy. Sin x minus y is the same as sin x cos y minus sin y cos x. And then divide the whole lot of it with cos x cos y. Then we divide sin x cos y over cos x cos y minus sin y cos x over cos x cos y. Okay. Then what's common? Here cos y remaining sin x over cos x, which is tan x. Here cos x remaining sin y over cos y, which is tan y. This is the left hand side. Done.
Makasiza sasa.
Sa ine vima right hand side, vima left hand vini panga G. Vini bwanji sa.
They were using
What about D?
nifunza nkoni.
This is the left hand side is equal to the right hand side. So when we say right hand side, we mean you will start with what is on the right of the equal sign. When we say left, we mean we'll start with what is on the left of the equal sign. So you choose a side to start with, because if they are equal, when you choose the other side, you must arrive at the other side. Exactly.
What about D? Sir?
Oh, what does this then?
No.
There where there is the tan x on the left side. If we are to write the identity, are we supposed to have sin x over cos x?
Yes, but remember
Next,
we have this. We have sin
sorry, my
x.
blanket.
We have sin x, we have cos x. Then we have tan x written in terms of sine over cos. We have cot x written as cos x over sin x. We have sec x written as 1 over cos x. We have cosec x 1 over sin x. So we are using these. We are using these guys here. Where we find tan, we change it to sine over cos. Where I find cot, cos over sine. Where I find sec, to 1 over cos. Where I find cosec, 1 over sine. Sine and cosec are related in this manner. Like sine squared x plus cos squared x is equal to 1. From this identity here, so many of them will come out, that identity. I demonstrate for you from that very identity. I said sine squared x plus cos squared x is equal to 1. Identity number 1. Identity number 2. From the very one, sine squared x plus cos squared x is equal to 1. If we divide throughout by sine squared, we divide throughout by sine squared, we divide throughout by sine squared, what we'll get is 1 plus cot squared x is equal to cosec squared x. 3, the same sine squared x plus cos squared x is equal to 1. If we divide throughout by cos, we'll get tan squared x plus 1 is equal to sec squared x. These are very serious identities in mathematics. This one, from the very sine squared plus cos squared is equal to 1. If you take cos squared the other side, we get sine squared is equal to 1 minus cos squared x. If we get sine squared, take the other side, we get cos squared x is equal to 1 minus sine squared x. So that is very, very critical. So you can have so many identities from this relationship of cos and sine. So many of them that are very, very useful in mathematics. Look at question I.
Sir,
Hello?
sir. What about the G?
I said I. Look at question I. Show that sine x over 2 is the same as plus or minus 1 minus cos x over 2. This identity can be asked in this way, or they give you some half angle to find. Okay, for example, they ask you to find sine 22.5. You can only find that angle using the half angle formula. So now, how do you prove that that is true? You get back to this identity here for sine. You come to this identity here. Is it this one? So you have options.
Sir,
Yes.
can we have an identity like the first one, where the sine squared x plus cos squared x is equals to 1? Now, provided that where there is a plus there is a minus.
But the other side won't be 1 there.
I don't know.
Yes, we can.
Now, what can be the answer if we have a minus?
What can be the answer if we had minus? Yes, so. Okay, first let's finish up I. It's like the minutes that are remaining are not that much. So for I, we want to have sine x over 2. So what we do? We need to use, not necessarily direct this, we need to use the double angle formula. For example, if you have sine 2x, sine 2x is sine, not sine 2x, cos 2x. Cos 2x is the same as cos x minus sin x, meaning that cos 2x is equal to cos squared x minus sin squared x. This is the answer to your question. If sine is 1, which is squared. Now, if we have this relationship here, then we are saying for us to get sine the other side, what do? We change this cos into sine. So we're going to have cos 2x is equal to, we can write this cos here as 1 minus sine. And then there is this minus sine. This is the same as 1 minus 2 sine squared x. Then we can take, since we have cos 2x is that, and we're looking for sine, so we can take this sine the other side and this cos the other side, so that we have 2 sine squared x is 1 minus cos 2x, and then divide by 2, divide by 2. So we'll have sine squared x is 1 minus cos 2x over 2. If we square root, you square root, you get sine x is plus or minus the square root of 1 minus cos 2x over 2. Like that. And when you get such a thing, you let a to be 2x, so that if you divide by 2, x becomes a over 2. So that where there is x here, we'll have a over 2 plus or minus the root of 1 minus, where there is 2x, we said it is a over 2. Then now again, you let a to be equal to x. So you're going to have your expression in the form sine x over 2 is equal to plus or minus the root of 1 minus cos x over 2, which is I. So using this very identity, if you change where there is sine here, you use cos, you find the half angle formula for cos. Same procedure. Very, very important. And using the very identities, you can find G.
What about D?
Even D. Where is D? Even D. You said that for D, you don't again use the tan direct. You switch it to cos over sine. Because if you use the tan direct, you have issues when you have minus tan pi over 2. That doesn't come out. So you attack it in the form attacked. Which guy? This A. Okay, so we have less than a minute. So you quickly log back because we're in a hurry. So we're coming to start from 11.